All right. Good morning and afternoon, everyone. My name is Jenna, and I'm a PM on the BeeAI project. Welcome to our second ever open source community meeting. Let's walk through our agenda for today. I'll start by introducing that the framework is now available in Python, which has been one of our most requested features. We'll then walk through our Jupyter notebooks that were crafted to help you get started easily. A highlight of today's session will be hearing from the community members who have built some incredible projects using the Python framework already. And then, of course, at the end, we'll have some time for some Q&A. We want this to be an interactive and valuable session for everyone. So if you do have questions as we go along, please don't hesitate to drop them in the chat. Our team will be monitoring and addressing them throughout the session. If you would rather share your thoughts verbally, we do have dedicated time at the end where you can raise your hand, and our moderator, Eden, can assist with unmuting you. So we heard your feedback from our initial prototype, which was developed in December of last year, which was fully TypeScript, and there was a clear demand for Python, and today we are so excited to announce that we now have an alpha release. Our approach to developing the Python version was very user-focused. We prioritized the core features that provide the maximum flexibility for developers to define their own agent architectures. So this really aligns with our philosophy of empowering developers rather than constraining them to rigid patterns. For models and tools integrations, we've taken an 80-20 approach, so focusing on integrations that provide the most value while keeping the framework lightweight and extensible. And looking ahead, we're doubling down on more production-grade capabilities next. And then the last point I'll mention is that the implementation was carefully crafted based on the TypeScript core, but it was also thoughtfully adapted to align with Python best practices. For next steps, we're very eager to gather feedback from early adopters like yourselves to understand what to prioritize next. Based on your input and your contributions, we plan to accelerate our timeline for a beta release. As of today, I'm very pleased to report that all of our core building blocks and extensions are fully available in Python. This includes our agents with the React pattern, workflows for structuring execution, several core model providers like Ollama, OpenAI, watsonx, Grok, with many more coming very soon. And for extensions, we have tool integrations for connecting to external systems like MCP and LangChain. We have memory systems for maintaining context and prompt templates. A few features like caching, serialization, version tracking, and instrumentation are still in development, but will be coming to Python very soon. But all of the functionality that you need to build your agent systems today is ready to use. Documentation has been a major focus for this release. We now have comprehensive guides that walk you through all of our available features in depth. We include embedded examples throughout the documentation demonstrating practical use cases, helping you understand not just how to use the framework, but why and when to use the different components. We put a special emphasis on explaining the transition between components, so how memory interfaces with agents, or how tools are integrated into workflows, and so on. All documentation is available in our GitHub repository today, and we will continue to expand it based on all of the questions and feedback that we receive from you all. To help you get started quickly, we've developed a series of Jupyter notebooks. Graham has kindly recorded a walkthrough of these notebooks, which I will play for you now. I might have to reshare to get audio here. Here we go.
Hello, my name's Graham White, and I'm one of the developers that's been working on the BeeAI framework for Python. And today I'm going to show some of the demonstrations of this framework via Python notebooks. I'm also conscious that I'm slightly standing on the shoulders of giants, of course, with these demonstrations, and there's a big community of developers and my colleagues that have been working really hard to make this come to fruition. So thank you very much to everybody that's been involved so far. So if I jump into the Python notebooks, we've got 3 of these that I'd like to talk through, and they show various aspects of the way in which the framework is working. And if I just start at the top, we have one for the basics of the BeeAI framework with Python. We have one that demonstrates how we use workflows, and I'll explain what that is later. And we have one that demonstrates agents, and by agents we mean our React style agents. So the first thing that we need to do when we're building an agent is to actually start to link out and think about how do we talk to our LLM. And so to do this, we have a system of prompt templates. And so the first cell and demonstration that we've got here actually shows us how do we create a prompt template. So we basically have a base class that we can extend, and the templating structure and style that we use follows the mustache style. So it means that we can inject variables into the templates that we want to create. And we have an example down here that shows us how that is executed as well. So in this example above, we end up with a context and a question that is provided as part of the input that would be sent to the LLM. Now, this first example, I'm not actually linking out to an LLM, so we are not sending this to an LLM. It's purely just printing out the result of creating or instantiating that template. As it says here, we can follow on that through and create more complicated templates. So we could put conditionals or loops, or again, any of the other sort of mustache style ways of working are compatible with the templates that we create. And here you can see a slightly more complicated example where we're injecting a particular, again, sort of structure into a more complicated template here. So executing that one, you can see how you would easily be able to build up a set of different search results, and you're still resulting in an overall template output using the variables that have been injected. So ultimately, you'd want to be sending this off to an LLM before we start talking about how we link that with agents. And in the BeeAI framework, our LLM abstraction is called our chat model. So in order to talk to an LLM, we must first learn how to instantiate the chat model. And that's done in this case by setting up first our user message. So we're going to have a piece of content that says, hello, can you tell me what is the capital of France? So that's ultimately the query that we're going to be sending through to our LLM. In the next cell, we are now starting to look at how do we link our user message to the LLM and execute it such that we get some kind of output. So when we execute this cell, it does take a little bit longer because I'm using OLLAMA in the background, and obviously we need to go and talk to the LLM and have that generate some tokens for us and ultimately give us the result. What you see here in the output, of course, is just the output of a direct call to the LLM using the user message that we've just created. So we're not operating as yet in an agentic fashion. This is how do we use the Python framework from BeeAI purely just to instantiate an LLM with a message. We also have the concept of memory. So for BeeAI, memory is effectively just like a multi-turn conversation. So we can inject messages into the memory, or we can look at the memory to see the pattern of the conversation that's taken place if we wish. So in this particular example, what we're doing is we're taking our user message that was originally created and the output that was created, and then we're asking a follow-up question. And so we'd expect in this case our LLM to take account of that historic conversation, that multi-turn chat, if you like, in order to answer that follow-up question. So if you had to recommend one thing to do they're referring to the previous input that we had, which was talking about Paris, and what would it be? And so our LLM in this instance has, from its own experience, not calling out to any other tools or anything yet, as I say, this is not agentic yet, is telling us that we should go and visit the Eiffel Tower and giving us some further information. So when we combine these two technologies that we've talked about so far, templates and messages, we can start to do more powerful injection of prompts into the LLM. And you can see that with this big example here, where we are creating a kind of like a RAG context, if you like, against which we're going to ask our LLM to answer a question. So in this instance, we're asking how much of Ireland is forested, and you can see the LLM has pulled out the answer from the context that we've given it, about 10% of the island, as it says here, and it's constructed an answer that uses that contextual information to give us the output that we desired. Something else that's quite desirable as well is the ability to, excuse me, to create structured outputs as well. So if you want output in a specific format, we have the capability to do that too. So in BeeAI, the way that we do that is by creating a schema and passing the schema to our chat model. So in this instance, we are creating or using the create structure call, passing the schema through, and then sending our user message. And so in this instance, with the user message saying create a fantasy sci-fi character for my new game and so forth, we would expect to see the structured output come back in the format of the schema that we provided, and for the LLM to imagine what the answer to that particular query is, but in that kind of structured output format. So you can see here that we've got JSON that is output, and that JSON conforms to name and then a string, occupation string, and so on and so forth. That is described in this character schema that we passed to our channel. Finally, one of the things that we often want to do, of course, is have an effect on the system prompt, and we are also able to do that not via a user message, as we've been talking about so far, but we can create a different type of message, a system message, continue to give it some content. So in this case, we're going to tell our model that you're a pirate, and it must answer the question using that particular notology, if you like. And so when we run this particular query, we see that the output comes in the format of pirate speak. And so those are the sort of basic building blocks and framework for the BeeAI framework with Python. That then allows us to go on and talk about workflows. And workflows are like a graph. So now we are starting to have the capability of chaining queries to an LLM together in a graph format. So the basic building blocks of our workflow are that you create the workflow, and then inside the workflow you add steps. And the steps can be call upon each other in a kind of linear fashion, or in a graphical fashion where you might make loops or subloops, any kind of graph that you can imagine. So the way that we do that is we have the concept of a centralized state. So in this simplistic example to start with, we have a message state that just holds our message for us. And we have a single step that we're going to execute. And the step here you can see is going to append the word world to a string that it's given. Further down, we create the workflow, we add our step, and then we run the workflow with the run method. And when we instantiate the workflow, we're going to start off by saying what our state should be. What's the initialization of our state? So we're going to pass in message equals hello. And so you would expect after this has run, it's going to execute both of those steps, and we append the word world through our first step to the word hello that we had initially passed in. We can add workflows that are more complicated. So if I run through the following set of cells that now start to build up a workflow with tools, you can see here again we are building up a state. We're connecting to, as I've been doing throughout all of these notebooks, the Granite model that's running on Olama on my machine here. For this particular example, we're going to be searching the web, and we use a tool called circs-ng to do this. So in order to execute this notebook, if you do try and follow along this example, you will need to get circs up and running. And I'll point out that there is a markdown document that will help you get that running in the background so that your notebook can call out to circs in order to make those web search requests. Okay, and so now I'm going to execute the example with tools. After creating the steps. Sorry, I'm getting a little bit ahead of myself. So this is the place where in this notebook, after going through all of those setup steps of adding the steps to the workflow, we're now going to create the workflow and define what those steps are. So in this instance, we're creating our workflow. Again, we're initializing it with a state, and we're adding, again, 2 linear steps that follow on from each other. So we're going to do a web search, and we're going to then generate an answer based upon the search results that come back from Circs that's running in the background, as I described earlier. So the first thing that it does, it executes the web search step, and that's going to do the search for the query. So what is the term for a baby hedgehog being our query? It's gone off and it's done a web search, it's pulled back the answers internally, and it's run then the second step that's generating the answer based upon all of the search materials that have come back in order to give this output that you see here. So we repeat the question, and then we give you the generated answer. Similarly to what we showed earlier, the workflows can have memory as well. So this gives us a way to, again, inject multi-turn into a workflow style agent. And in this instance, what we're doing is we're creating an infinite loop here. So whilst true, it's now looking for some input. So you'll notice we've got an input box down at the bottom. And now I can type anything I like. So people often type hello to these types of bots, and you get the kind of standard, hi, I'm a bot type query. And now you can dream up of any kind of question or prompt that you might want to give it. So write me school report for Taylor Swift when she was 11 years old, in the style of her favorite music teacher, some kind of random query like that. And this will then go off and it's going to search the web. It's going to pull back results, in this case of Taylor Swift, maybe what she was doing when she was 11-year-old. Hopefully it's going to meld and merge all the information about the fact that she would have studied music and she was quite a talented musician. And come up with something, I'm not going to read this in any great detail, but something that looks hopefully vaguely plausible. And then, as you see in the loop here, you can type exit, and we would exit this particular workflow from the infinite loop that we've created. Okay, finally, onto the React style agents. So this is another way of creating an agentic workflow inside the BeeAI framework. And in order to do that, we use the instantiation of BeeAgent here, and we pass it the chat model so that it knows how to connect to our LLM. In this instance, we've got some observability that is going to explain to us as an observer what the agent is doing. So when we execute this simple example of what a BeeAgent looks like and pass it what chemical elements make up a water molecule, you can see that the agent has a thought, and then the agent creates a final answer. And similarly, once again, we can now start to pull tools into our React agentic workflow. And in order to do that, we can use either built-in tools, you can write your own tools, or you may import tools from elsewhere. I'm not actually going to run this cell because this is currently running really slowly for me at the moment. I don't know why, but OpenMeteor seems to be running a bit slowly today. But basically, you can import the OpenMeteor tool or other tools from the BeeAgent framework code, the library. Then you can inject them into your agent using the tools array. So here you can see we've instantiated our OpenMeteor tool as part of the tools that we're passing to the agent, so that we can ask a query something along the lines of what's the current weather in London. And you can then see, again, via the observability mechanism, that the agent's had a thought, and it's gone through its React process in order to give us the current weather at the moment is 11 degrees C, with some relative humidity here in the UK near London. We can also import tools, as I said, so you don't have to create your own tools. So this example is actually showing how to use the Wikipedia tool from the LangChain library. So if I was to execute this particular example, you can see how we wrap the LangChain tool into the BeeAgent framework, such that we can pass it to the agent and have the agent execute that tool on our behalf. And again, we've still got the observability tied in here, so we're getting all the React loop printed out, as well as the final answer of the agent. In this case, we were asking who's the current president of the European Commission. So it's gone off and it's done that search again for us through Wikipedia using the LangChain Wikipedia tool. And finally, we also have this @tool decorator. So you can rewrite your tools. If you write a tool that using this kind of long form way of writing tools, you can actually make your tools a lot shorter by decorating them with @tool. putting a lot of the information into your PyDoc here, or your doc string, and then executing the tool in exactly the same way. So we're still connected to a React agent. We're still passing the tool into our agent, as you see here, but now we're just taking advantage of that decorator that allows us to write much more succinct code. And again, you can see the answers coming out correctly. Okay, so that's the end of the walkthrough of all three of the notebooks, the basics notebook, the workflows notebook that allows us to work with graphs, and the agents notebook that gives us the React style way of operating. All of this in Python, and yes, hope you enjoyed the demos and learned something. And thanks again to all my colleagues that have helped create this. Bye-bye.
All right, wonderful. So as you can see, the notebooks are designed to be very interactive and provide you with kind of a structured learning path and getting comfortable with the framework. So that was wonderful. Thank you, Graham. And now we get to see what our community has built. So we have some incredible demos lined up from some very early adopters of the Python framework that really showcase its versatility and power. So I'm really excited to jump into this next segment. First up, I have the pleasure of introducing you all to Matthias, who's going to be walking us through his project, Evolving Agents. Over to you, Matthias.
Hi. Hello. Well, basically what I am doing is a framework that is using Bee, because I started using Bee for a production system, a small system where I create a help desk using a React agent. And I started, it's an amazing framework because the only thing that I need to do was define the tools. The issue with my approach was that I started to use more tools in the same agent. And I tried also to use the smaller model that was Llama 8 billion parameters, Llama 3.1. I start to find that when you have more than 2 or 3 tools, the description of the tool is very important to have a smooth workflow with the user, a smooth interaction, and in some way provide the actions that you want to provide in the help desk. For example, provide an assistant or save an issue. And also I realized that using the same model from different providers, you have some difference. I tried Vertex, I tried Grok, I tried Olama, and sometimes there is a small difference. So I start to realize that I always need to evolve the description of the tools, the code of the tools, and at the end, with new models and new providers, or with new features, I need to review all the things. And also, when you are using a tool, for example, you have several intents, because sometimes you are calling a function, an external function, and the LLM is not generating the right way to call that. So I realized that it's obvious that if you, in some way, you detect what is the right way to do something, makes sense to save the tool, to save the function, to save the logic. And this is probably the idea behind this framework that is evolving agents. And it's more a POC that is exploring things over the Bee, because Bee is an amazing framework. And I think that the idea of use a framework is build something over the framework, not reinvent the wheel, basically. Then I try to do that. What I will try to show you is a proof of concept in that I am working. Let me try to share the screen. Okay, I have a repository of my project that is this. And basically what I am trying to do is how I envision the things. And please also, I want to say thanks to Ismael, because he's giving me a lot of advice, and I am discussing with him some ideas. And again, these ideas are probably ideas to explore or evolve for future features, or maybe it's not for problems that to apply in production nowadays. I switch, and I am using the Python framework now. Thanks for the Python framework, because it's more easy to generate code with LLMs and integrate the new things in what I am doing. Basically, I am using LLMs to generate my code all the time. I can only review and refine the ideas. And what I am trying to do is, because I start to try to reuse the agent and the tools, I have a sort of library that I call Smart Library, because basically is what I am trying to do is save and reuse agent and tools, and have a sort of metric to decide if I can use a tool that I already have, or I need to create one from the scratch. That is something that I am trying to do also. And let's say that I have one definition in the Smart Library that I can use, or I need to create one from scratch. I am using the factory pattern to try to do that. I have a pattern for the tools also. And what I am trying to do also, I realized that basically I am working with agents, and I am creating agents, or I am programming agents to do something. But I realized that my framework or my ideas are not using agents from design. Let's say, before I start with this project, I was creating standard software components, but not agents. So something that I try to do here is, okay, I have a Smart Library. I want to reuse tools and agents. What is the component to do that? Is a standard component, or is an agent that has the responsibility of analyze the Smart Library or maintain the Smart Library and give me agents and tools? And that is the approach that I am that I am using. Right now is a draft. I need to refine the interface and the services that I am providing, but basically I have the Smart Library here. I have a LLM services that is using also behind of my classes. I am using Bee, basically. And because it's a draft, I am using in some places only some features. My idea is use all the framework, try to build something to explore more features, but on top of Bee. Also, something that I realized is that if I try to create new agents from scratch and new tools, and I am applying these agents to a specific domain, I need a sort of control. One that I am exploring is how it try to have a firmware that is basically something that right now we can add to the system prompt. In the system prompt, we are defining some rules that the agent is using for all the things that it's doing. Okay, in this case, I am trying to add some things to all the system prompts, basically. Then, for example, if I am creating agents for a medical app or for medicine, define some, for example, some things for this domain, and be sure that all the agent and the tools that I have in the system are taking that into account. Again, trying to do all this, I realized that it's complex to implement in detail all these things. And basically, what I am trying to do is create the main components and create an example, and I am realizing what I need to improve. I have two examples. One is a more complex example where I am trying to implement communication between agents. And I saw that you are starting to work on this featured communication and also a sort of mechanism to use to reduce the register the agents and use them. I think it's the ACP feature. Basically, I have a lot of ideas in common, and I am going to adopt the approach that you are using. Sorry. In making real cases and trying to make all these things work, I am realizing that there are some problems to solve. Right now, I have for example, a small sample that, and all this, if you check the repository, maybe it's 1 or 2 weeks old, it's very new, it's a draft, it's a work in progress. But what I am trying to do right now is I register the simple tool for the weather in the smart library, and I am reusing this tool using all the things that I have. Oh, sorry. I think I stopped to sharing. No, I'm sharing. Then I will try to run the example again. This example is in the repository. And basically, what I am doing is first I am creating the tool in the library. The library right now is a JSON file, and after that, the system agent is creating an agent with this tool from the library, and I am using it. I don't know if it is okay. What I realize is, or what I am doing, if you check the other example, I have a lot of mocks. That is, instead of use real agent and real tools, I am creating small pieces of code, functions, that is giving me the same result if I call a microservice or an API, or if I call a LLM to do something. But the idea is to discover what are the issues trying to do that in order to implement this approach properly. Some things that I detected is that depends on the library that you have and the size of the system that you have. It's very important how you describe a tool or how you describe an agent and how you try to look for an agent or a tool, because if you, at the end of the day, if you are looking for a very specific task, you need to describe or you need to provide a better context for the discovering, to discover the tool or the agent. And I am working on that. I started with very simple descriptions, and I think I need to improve that better. Again, what I am trying to do is starting with simple cases, like have a tool that works with an LLM and with a description for a use case. But I realized that that is a challenge, how to describe the tools and the agents in the library. I have a more advanced example here. And if you try this example, that is a communication between agents, I have a lot of mocks here, but there is a very interesting thing in this example. In the same way that I started with ideas and I generate the code for this framework with a LLM, I generate this example using a LLM. Basically, it has two parts. One is to create the definition of the library, and the other one is use the mocks agent and tools. One to process an invoice that is a financial domain, and the other one is to process a medical record that is another domain. So the idea is to test the different firmwares for different domains, and also communication between agents. And here I have a very interesting behavior because something that I mentioned is, for me, makes sense that a new framework for agents and to support evolving agents and for the future needs to have agents as components in the system. And I already have one component that is the system agent that has the responsibility of look for agents and tools in the smart library, use the agents or create new ones. And doing this example, the LLM creates a new one. This is the setup. Creates an agent communicator tool. That is an agent that allows me to send message between agents, basically, and analyzing the example or refining the example. And I am working on this example. This example is working also. You can test, but it has a mocks in a lot of places. And the idea is that I realized that, for example, this tool maybe is a tool for the system. It's not an additional tool for the library or it's not an optional tool. So basically, I realized that the approach makes sense. I try to create a system or a framework. It's not a framework. It's like additional tools for Bee on top of Bee to make some things that right now is a proof of concept, and to try to solve problems that appears when you try to use in production and in real problems, real use cases, the framework. For me, when I try to use an agent with several tools to deliver a help desk support, and after that, exploring how I can use more agents than one agent, and also agents with agents, not only agents with humans. I start to understand that there are several problems that need to be solved, and that is what I am trying to explore here. If I run this example, also here I think I have the library, and basically what I am doing for now is I am defining all the agents that I need and the tools in the library, and I am using the basic approach. That is, retrieve the agent and tools from the library I am using semantic search, but here the challenge is semantic search regarding to what? To the description, and I need a better description or a better criteria if I have a lot of agent or tools. I have the code, but I think show the code for the search is a bad practice because I am thinking in object-oriented programming, and the idea is to try to encapsulate the implementation and allow the implementation to evolve. And I saw that this is very similar to what you are starting to do with ACP. So my idea is to migrate to that and try to contribute improving or sharing ideas of how to do that. If you try to run this example, it's running also. In the next days, I am going to replace the implementation that right now is a mock or very simple things with real agents and tools. And that is what I am doing. And all that using the Python framework.
Wonderful. Thank you so much, Matthias, for sharing. This is fantastic. Right. And up next, I have the pleasure of introducing you all to Dean, who's going to be walking us through his Docker Bee. Over to you, Dean.
Sure. Thank you for having me today. So my name is Dean Channer. I'm a consultant with the U.S. Federal Group, working as a AI solution engineer. And so, one of the things that we do quite often, especially in the U.S. federal market, is we're still doing a lot of code migrations, modernizations, things like that. And so, with AI, getting into that space, one of the things that we've noticed that, we can throw some code at an AI and it can start to modernize it, move COBOL to Java, Java to Python, things like that. But that doesn't always get us in the cloud or get us into a containerization environment. And so one of the things that we set out to do a couple months ago was just see, can we take a legacy README, out of a GitHub, and write a Docker file with AI so that we can start to containerize these apps that we're modernizing. And so we actually were able to do that in the fall. And we actually used LangGraph as our framework back then. And so, really got good results. And so when the Python, kind of pre-alpha dropped a couple of weeks ago, really kind of wanted to see, how easy could we port that LangGraph implementation over to Bee, especially, using the workflows. Because one of the things that we noticed when we were doing the original implementation is that we really got better results if we turn the Docker file back on its end and asked, a model to verify the results. So, we really wanted, a little bit of a deterministic flow. Create the Docker file and then have another part of the flow that says, hey, verify this Docker file against the original README. And so that's what we were able to do. And actually very similar to, what Mateus was saying, one of the things that, we learned in both when we were doing this in LangGraph as well as doing in Bee, picking the right model for the situation, is important. Making sure the model is up to the task. And so, and also the other thing is, sometimes you do have to write some really simple tools just to interact. And so in the example that I'm going to show today, I wrote a simple, kind of markdown reader tool. We also originally wrote some tools that actually went into GitHub, pulled down that README, read that README. I didn't port those tools over to this example, but you can kind of extrapolate how easy it is, with a framework like Bee to go in and use some simple tooling to interface, with different APIs and get some of the information that you need. So before I show the demo, some of the key learnings, that I went through kind of both as I was walking through the Python notebooks that were shown earlier, and then also just kind of, as I was porting, especially users of Olama, got to be real careful about, how we pull our models down and making sure we're very specific and we know, what we name those models as we pull them down, and we interface them, because sometimes, the default name on the Olama website is not always the name that we pull them down. So, that one took me a little bit to catch because the error messages, weren't very clear there, and I think there's been some chatter in the Slack channels and the Discord channels around that, so that was very helpful. Looking forward to seeing some more things around, being able to kind of identify when we are using heavy workflows, being able to identify and visualize that flow, both in the code and maybe in a GUI type experience. I will admit, as a lane graph early adopter and now as a Bee early adopter, I don't think it wasn't very clear to me in some of the examples is kind of where the start, the middle, and the finish was for the flow. I kind of had to guess, and I can see where that's going to trip some users in the future. And then, of course, really was pleased with, what I found, and so excited about being able to do more, with UX and, deployment. As you mentioned earlier, Jenna, that production level support that's hopefully coming to the Python side of Bee in the next couple of months. So definitely very, very excited about that. So with that, let me share my screen and I'll kind of just walk. I'll share the example and then walk us through real quick. Um, so um, yeah. I'll so classic, README file, example of a legacy Java app README file, right, that you might find in your project, shows what Java is supported, and it's definitely got, places in it where normally a human will want to kind of fill in the blank, like the project version and things like that. So what we were able to do is I'll run it. Is so the agent's going to go through and just that README, and like I said, you could right now it's just reading it from the local environment, but you could definitely easily extrapolate a tool to go get it from a different GitHub. So I was able to read the README and then ultimately create that Docker file. And what I'll point out, as you can see, based off of how and I hard coded the prompt here, but you could definitely have the user prompted, hey, here's the version I want to use. You can see where the AI was able to replace things like project version in the Docker file and run it. And ultimately, one of the things I am excited about trying, and I haven't had a chance to, is actually trying out some of the code running tools that Bee has, and I want to actually try to run this Docker file and see if it'll run, because that was one of the things that we didn't have when we originally did this several months ago. Is a framework. We would have had to create our own kind of framework that provided that sterile environment that Bee's providing. So super excited about that kind of coming over to the Python framework as well. Was there any questions in the chat or anything on this? Awesome. Well, I'll turn it back over to you, Jenna.
Awesome. Thank you so much, Dean. This is really cool.
Mhm.
Let me go ahead and share back my screen. Yeah, so this brings us to to questions. I know we covered a lot today. I'd really just like to open the floor up to everyone to see if they do have any questions. Feel free to use the raise hand feature, and Eden can, I know you can't unmute yourself, but she can go in and unmute you, and we can chat. Otherwise, yeah. And this is recorded as well, so we can always post it and follow up with questions in Discord and everything. So I appreciate everyone being here and for all of our amazing demos that we got today. And have great days. Thank you so much.